Hello everyone. In this lesson we're going to look at graphing linear inequalities. Graphing linear inequalities works in the same manner except for a few steps as graphing linear functions. And we're going to examine how it's similar and how it's different. So recall graphing in slope-intercept. Y equals mx plus b. You plot your y-intercept, plot y-intercept, then you use your slope. And in the second type, which is standard form, it's ax plus by equals c. I would definitely just find my x-intercept by setting ax equal to c, plotting that on your plotting that on your x-axis, and then find my x-intercept by setting by equals c, plotting that on my y-axis. Another type is if you have horizontal and vertical lines. I don't think I discussed that enough in the previous lessons. Horizontal and vertical lines. If you have x equals a number or a constant, or y equals a number or a constant, x equals a number is a vertical line. If you see y equals a number, it's a horizontal line. And of course, c is just equal to a constant or a value. Vertical lines, if you will recall, have an undefined slope, and horizontal lines have zero slope. So if I've got x equals 2, then that's going to be a vertical line through the x-axis at 2, and slope is undefined. Also, what slope undefined would look like in a fraction is 0 would be on the bottom, slope being undefined. You can't divide by 0. And y equals number or horizontal line. Let's say I have y equals 1. Then that would be a horizontal line through 1 on the y-axis. Slope is 0, and what that would look like in the slope formula is if 0 was on the top. The next thing you have to remember about graphing linear inequalities is if you have a solid line or a dotted line, and you get to shade and you get to color in this lesson. So you are always going to put a dotted line if you see a greater than or a less than symbol. We use a solid line when we have greater than or equal to, less than or equal to. And you also have to determine the shading. So whereas when we're graphing linear functions and you graph the line, that line is your solution, or the set of ordered pairs on that line is your only solutions that will work for that equation. However, when you have an inequality, an entire bounded region and any ordered pair in that entire region can be your solution. So to find the area that you shade, or in other words, that's your solution set, then you have to test ordered pairs in your regions. So test ordered pairs in both or all regions. And you'll see what I'm talking about in a second. And I'm going to take, this is actually, I'm going to work through your 1.4 homework set, and this is number 1. It says, what is the graph of the inequality? And we have 25y is less than or equal to 30x. Oh, I want to go back up here and make a note really quick. Vertical or horizontal. If you only have x or y given to you, like if I just have an equation or inequality that contains x, or an equation or inequality that only contains y, you automatically know it is a horizontal or a vertical line. So if your equation or inequality only has y or x, you can automatically know that you would have vertical or horizontal lines. All right, going back to number 1. Graph this inequality, and notice that this is actually pretty close to resembling, this looks like y equals mx plus b. Or it also is very close to resembling ax plus b, y equals c if you get x and y on the same side. It really doesn't matter what you do, but the only thing is, notice that if you get x and y, if you were to put this in standard form, you would need x and y on the same side. So in that case, I would actually move 25y over and say 30x. Notice that the sign is, the bigger part is with 30x, or opening up towards 30x. So 30x is greater than or equal to negative 25 30x minus 25y. So sorry, the sign is opening up, so it's a greater than or equal to 0. So you took everything away from the side, so you're left with 0, and then moved it. And all I did was flip the whole thing around. But anyway, if I were to find my x-intercept and my y-intercept, notice that they would actually be 0. Because if I set this equal to, if I set 30x equal to 0 and solve, I'm going to get 0. Negative 25y equals 0, solve, I'm going to get 0. So that really gets us nowhere. So you definitely want to put in y equals mx plus b. So what we're going to do is I'm going to divide through by 25, and that's going to give me 30x divided by 25. And then let's go ahead, that will definitely reduce. So y is less than or equal to, divide both of them by 5, and you get 6/5 x. So that's my equation I'm graphing. Notice that your y-intercept is what? There's nothing added or subtracted at the end, so it's 0. And this has a positive slope. My y-intercept is 0, so we can start at the origin. And I use my slope of 6/5, so I go up 1, 2, 3, 4, 5, 6 places, and I go to the right 1, 2, 3, 4, 5. Put a point, and let's reverse that to find a point down here. From this point, I'm going to go down 1, 2, 3, 4, 5, 6. To the left, 1, 2, 3, 4, 5. Put a point. Now, before you draw your line, don't get too hasty because I make this mistake a lot. Look at your symbol. And notice that you would get a solid line because it contains the equality part. So your steps, if you want to write steps down, or if you want steps rather to do these, the first thing you're going to do is graph your function. And the second thing that you do, okay, graph or plot your points is the first thing. Second thing that you do is determine if you have a dotted or solid line. And then the third thing you do is you have to test ordered pairs. Test ordered pairs in both regions to see where you shade. So test ordered pairs, and then finally step 4 is when we're going to shade. All right, so here we go. Like I said, I know that I have a solid line. And now you want to test, I'm going to test my order pairs. All right, let's test. And how you know where to test, okay, notice that I've got this whole region on this side of the line, and I've got this whole region on this side of the line. So you test any order pair in this region, and you test any order pair in this region. I'm going to, of course, pick an easy one. So I'm going to pick 0, 1. So I'm just going to pick a point up here and test it out and see if it works in this. Or actually, you can see if it works here. So if we test 0, 1 from this region in 25y less than or equal to 30x, you plug in 1 for y, plug in 0 for x, and let's see if you get a true statement. So if I plug in 25, if I plug in 1 and 0, notice that I get 25 is less than or equal to 0. And we know that's not right. And this only has to satisfy one of those conditions. Remember that. 25 is definitely not less than 0. 25 is definitely not equal to 0. So it didn't work either. It didn't satisfy either one. So we know we are not shading above. And our region is not there. Now let's test. I'm going to test. Let's pick an easy one. I'm going to test 1, 0. So let's test 1, 0, plug it in, 25y less than or equal to 30x. You can plug into either this, your original, or the one that you transformed. Either way. So when we plug in 25 times 0 less than or equal to 30 times 1, you get 25 is less than or equal to 30. You get 0 is less than or equal to 30. And that definitely is a true statement. Once again, I told you it only has to satisfy one condition. 0 is less than 30. So I don't care about the other part, that 0 is not equal to 30. It's less than or equal to. So since I know I'm shading on this side, since I know I tested that region and it worked, then that means that any order pair in this bounded region will satisfy your graph. So that's how you graph inequalities. It's not just one single line of order pairs that actually works. It's a whole entire shaded region on your graph that would work in this. And we just proved that. We just picked an order pair on this side, tested it, and it worked. Picked one on this side, tested it, and it did not work. Okay, the next type of problem is it actually just asks you to do really kind of what we just did. Is the order pair a solution? So number 2, we have 5 ninths and 0, and they want to know, is it a solution to the inequality 2x plus y greater than 1. So simply you just take and plug in x for 5 ninths, plug in 0 for y, and then multiply you get 10 ninths when you multiply straight across with fractions, and plus 0 gives you 10 ninths is greater than 1. 10 over 9 is greater than 1. This is actually 1.1. So that is true. So yes. Okay, we've already graphed one in slope-intercept form. I'm going through your homework problems really quick. Number 3, it says graph. Well, this is like number 4 in your homework actually. Y is less than -2. We know that this is a horizontal line through the y-axis at -2, but you need to remember this is dotted because it only has the less than sign, and then we have to determine where to shade. Well, these are actually really easy on where to shade. This tells you you're wanting to shade where every y is less than -2. Well, if we go above on the y-axis, all of these y's are definitely greater than -2. So we know we're shading down underneath. And how you can actually test this region is plug in a number on the y-axis above. Like if I plug in 0, 0 is not less than -2. Number 4, graphing x greater than or equal to 1. That is going to be a vertical line through the y-axis at +1. And it's going to be solid. And it's greater, so you're shading in the area where all your x values are greater. So it would be to the right of that line. This is number 4, but this is just like number 7 in your homework. It says a freight elevator has a capacity of 3,000 pounds. Elevator capacity 3,000 pounds. It goes on to ask you in part A, if a barrel averages 40 pounds and a crate 120 pounds, write an inequality that describes when X barrels and Y crates will cause the elevator to be overloaded. So in part A, we've got a barrel is 40 pounds. A crate is 120 pounds. And write an inequality to describe when the elevator would be overloaded. Okay, so what you want to do, I've got X amount of barrels that weigh. We'll let the barrels be X and we'll let the crates be Y. You can use whatever variable you want. MathExcel does not care. You can use B and C for barrel and crate if you want to. So 40 barrels plus the weight of Y amount of barrels that weigh 120 pounds. Now, they tell me that the elevator has a capacity of 3,000 pounds. All right, let me go back. Sorry, I didn't realize you couldn't see that on screen. Barrel weighs 40 pounds. I've got X number of barrels. Crate, 120 pounds. Y number of crates. Elevator capacity can only carry 3,000 pounds. So if I've got X amount of barrels weighing 40 pounds, Y amount of crates weighing 120 pounds, I cannot reach 3,000 pounds. I have to make sure that my capacity and my weight is always less than 3,000. So I would say the weight of the barrels plus weight of the crates is less than 3,000. So there's part A. Then it goes on in part B to tell you to graph it. So part B, graph the inequality. In this case, this is in standard form. So if you'll recall, in standard form, we graph these by finding the x-intercept, set your x term, and I'm going to set it equal to 3,000, okay? I'm not going to pay attention to the less than sign just yet. So 120y equals 3,000, and then we're going to see. 3,000 divided by 40 is going to give you 75. And then 3,000 divided by 120 is going to give you 25. To make this easy on you, you can definitely go by 5s if you want to, since 5 will go into both of those. So let's do that. I'm going to say that this is 25, 20, and 15, 10, 5, and then 0. Okay, 75 would be there. Let's go ahead and plot our x-intercept of 75. Plot our y-intercept of 25. And then go back. You have to determine this would actually be a dotted line. And so we draw a dotted line between them. And then we have to determine, are we shading to this side or above my line? Am I shading to this side or below my line? And we have to test the point. And I want you to know, I want you to like try to make this as easy as possible for you. I always pick an easy point. So I want you to look, the origin is very easy to pick. If I pick the origin and it does not check out in this inequality, then I know I'm shading here. If I pick this ordered pair and it works in this inequality, then I'm shading on this side. So let's test 0, 0, since that's the easiest point. And I'm going to test it in 40 times 0 plus 120 times 0, and I'm going to see, is that less than 3,000? And it definitely is. 0 is less than 3,000. So I shade this way to this side. So that means that, and that only makes sense. Think about it. If you reach anywhere above, because this represents your crane, your crate maximum. This represents your barrel maximum. So you can't expand that anymore or you're going to go over that weight. And that was number 7. And your last one on the homework. Okay. All right. And that was graphing inequalities. Thank you. Have a good day.